Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to construct congruent segments, perpendicular bisectors, congruent angles, angle bisectors, and parallel lines using a compass and straight edge, as well as how to increase the length of a line segment and increase the measure of an angle using a compass and straight edge. How are we learning it? Through the construction review notes and the constructions review assignment. When can we use this information? To create matching sets of furniture or recreate a piece of furniture, to cut boards into smaller equal pieces in order to create or repair furniture, and to recreate a piece of furniture or decoration by increasing its size. How do you know you learned it? By getting a score of 4 on the constructions review assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, I'll give you time to complete the constructions review assignment. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the constructions review notes. The notes begin with the learning goals and success criteria. So what is a line segment? A line segment is a straight path that has endpoints on either side. So it looks like this. So we have a line here and it ends on both sides. Now, how is that different from an actual line or a ray? Well, a line segment has endpoints on both sides. A ray extends without end, meaning it goes on forever in one direction and has an endpoint on the other side. So here we have an endpoint, and this one goes on forever this way. And then a line extends forever with no end on both sides. Symbolic notation for line segments. When we talk about a line segment, we label it as AB. So it's the two endpoints, so A and B. So if this is A, this is B, we would call this segment AB. And it's written just like this. Geometric notation for line segments. Line segments are shown geometrically by labeling the endpoints on the line segments. A dash is typically drawn through the line segment to demonstrate the segment length. So for instance, we have a segment here with these two endpoints. Congruency and similarity. Congruent line segments are line segments that are of the same size, shape, and angle measure, so they're exactly the same. And the way we write that is AB is congruent. This symbol means congruent. So AB is congruent to CD. Similar figures have the same shape and angle measure but have a different size. So we'd have a line segment that is half of the original or a third of the original or something like that. And the way we write that is AB is similar to CD. So congruent is an equal sign with the squiggly over the top. Similar is the double squiggly. So congruency versus similarity. Congruent figures have all the same sizes. So notice all of my triangles here, both of my triangles, have exactly the same angle measures and same side lengths. They look exactly the same. That is congruent. Now similar means that it's blown up or shrunk down. So it's all the same size and shape. It's proportional, but it's not the same size. It blows up or shrinks down. So we can see that this triangle here is this one blown up. Geometric notation for congruent line segments. So line segments are shown geometrically by labeling the endpoints on the line segments, and congruent segments will be shown with the same number of dashes through the sides. So for instance, we have a triangle here, and on this side, you can see we have a single dash, and on this side, we have a single dash. That means that those two sides are exactly the same length. Then we have a double dash here and a double dash here. That means those two side lengths are exactly the same. And then the same thing with the triple dash. So triple dash and triple dash are all congruent to each other. Now there's a video here that shows you how to construct congruent line segments using Desmos. So go ahead and watch that video now. Let's take a look now at how we can construct congruent segments using Desmos. So we're given a segment here, and we're going to go ahead and create our pop-out menu. So we click on this button here to pop out our menu. And now we have a line segment here, and we need a baseline to match it. So I'm going to use the ray tool, and I could create a ray in the same direction, or I could do it in a different direction, something like this. Either way works. And now I need to create a circle with this radius here, and then if I copy that up to here, that should give me the exact same distance. So I'm going to go to More Tools and click on Compass. Then I'm going to go to the segment that I started with and click on it. And notice now it creates a circle. And if I put the center of that circle here at this point, the circle is going to pass through the other point, which means it has that radius that I want. So now if I bring it up and place it here and click, notice it creates my circle, and I have a point of intersection. And I know that this radius is the same as this one, so that means this distance matches this one. So if I put a point where they intersect, that means that the segment from here to here is exactly the same as this segment here. Now there's a video here that shows you how to construct congruent line segments using paper and a compass. So you can go ahead and watch that video as well.
To copy a segment using a safety compass, first you need the segment. Next, using the compass, go ahead and make a ray down here that is longer than your given segment. Using that ray, we can measure the segment up here using our compass and go down to the ray and copy it. Go ahead and line up your little brass ring there in your safety compass with one of your endpoints. One of your other holes along your compass, along here or on the bottom, one of them should line up with the other end of your line. In this case, it looks like this one right here by my arrow. Goes right through there. Remember which hole you used, come down to the ray that we created, recreate that movement. Line up the brass ring at the end. Remember which hole you used. I used the one right here by this arrow. Go ahead and mark that off. What we've done is we've cut off a piece of that ray, creating a segment. We have an endpoint and an endpoint. This segment is now exactly as long as that segment. And that is how you copy a segment.
Now what is a perpendicular bisector? Perpendicular lines are two lines that form all right angles. And right angles are 90-degree angles. Bisecting line segments means that it cuts the original line segment in half. So it cuts it into two equal segments. So an example of this would be here. So we have our original line segment here. If we were to cut that in half, if we were to go halfway through, it would be right here. And then when we draw our line, it forms all right angles here. So this is a right angle, right angle, right angle, and right angle. So that's a perpendicular bisector. Now, how do we construct perpendicular bisectors? There's a video here that shows you how to do that using Desmos. So go ahead and watch that video. Let's take a look now at how we can construct perpendicular bisectors using Desmos. So we're given a segment here. We're going to go ahead and pop out our menu. And what we want to do is we want to create a circle around each of these points that passes through the other one. So if I go to the circle tool and click on it, and I create a circle that goes from here and extends out to the other point, just like that. So now I have one circle, and now I need another circle that's exactly the same size with this as its center. So I'm going to use the circle tool again, and this time I'm going to click on this point and extend it to here. And notice now I have two circles, and I have two spots where they overlap. Right here and right here. So I'm going to put points right there. So now those are my 2 points. Now all I need to do is use the segment tool to connect those 2 points. And what I should have now is my original line segment cut perfectly in half, so that's the bisector part. And then each of these angles should be exactly 90 degrees. So that's the perpendicular part. So this is how you construct a perpendicular bisector. Now there's a video here that shows you how to construct perpendicular bisectors using a paper and a compass. So you can go ahead and watch that video as well.
How to bisect a segment. First, have a segment. Next, go ahead and get your safety compass and line it up, the brass ring, with one of your endpoints. Then, pick one of your marks along your compass that is beyond halfway across your line segment. That way that we can make an arc above and below, come to the other end, do the same thing, and somewhere those two arcs will crisscross. So, I'm going to come over here, beyond halfway, and pick this mark right here. I'm going to go ahead and make an arc up above. And I'm going to come down and do the same thing down below. Now you have to remember which hole you used. It looks like 2, here's 3, so 2.5 right in the middle by that bold line. Come to the other end. I'm going to do the exact same thing using the same hole. For me, it might be a little bit different for you guys. There's 2.5 there, and come up here, 2.5 up here. Alright, I have a crisscross up above, crisscross down below. If I connect these two just right, I will create a nice line that chops right through here. So, notice over here I have this is a special construction. Not only does this bisect a segment, which means that it chops it in half so that this side is exactly the same size as this side. If that bisects it and these two pieces are the same, this also creates a midpoint right here. So the bisect of a segment also creates a midpoint. One other special feature about this is that this bisect line here is also constructed at a 90-degree angle. So, in this one construction, we've created 3 different things. We have bisected a segment, which means we've chopped it in half. Because of that, we now have the midpoint, and we also have a perpendicular line. So this line going through here can actually be a perpendicular bisector. This is a 3-in-1 very special construction, and that's how you bisect a segment. Create a midpoint, or create a perpendicular bisector.
Now, what is a parallel line? Parallel lines are 2 lines that continue endlessly and never cross each other. So, if these continue on forever, they still will never come together and touch. Those are parallel lines. Now, there's a video here that shows you how to construct parallel lines using Desmos. So go ahead and watch that video now. Let's take a look now at how we can use Desmos to construct parallel lines. So we're given a line here and then a point that we want it to go through. So the way we do it is this. We're going to use our menu. So we're going to create our pop-out menu. And we're going to use the line tool. And I need a line that goes through this point and through this line. It doesn't really matter what it looks like. Doesn't matter where it passes through. I just need it to look something like this. And notice now I've created an angle here. Well, if I can copy this angle, that means that this angle and this angle that goes through here have to be the same, so these lines have to be parallel. So let's go ahead and do that. So I'm going to go to the circle tool and treat this like an angle. So just like that. Now I need to use my segment tool to connect these 2 points. So that gives me my radius. Now I'm going to copy that radius up here. So let's go ahead and do that by using the compass tool. So I go more tools, compass, and I click on this segment here. Notice it gives me now a circle the same size. So I go ahead and click right there. So there's my first one. Now I need to copy this distance from here to here. So I go ahead and do that. I'm going to click on a point so I can have a point here. And then I'm going to use the segment tool to create my radius here and here. So there's my radius. Now I'm going to copy that up to here. So I'm going to use more tools, compass, here. And I want it to be where they intersect. So where this circle intersected this line. So I'm going to go ahead and click here. And notice now I have 2 circles that overlap. So I'm going to go ahead and use my line tool now to connect this point and this point where they intersect, which is there. And notice now I have 2 lines that are perfectly parallel. Now there's a video here for you to watch on how to construct parallel lines using paper and a compass. So go ahead and watch that video as well.
To construct a parallel line through a given point, 1, you need a line and a point not on that line. Obviously, if it's on the line, you're not going to have a parallel line. So, first step, we need to draw another line that goes through that point and also through this line. It doesn't matter how you do it, as long as you create a line. You can create the line straight up and down, you can slant it, as long as they intersect both of them. Because now what we're going to do is we're going to copy this angle right up here so that this line and another line that I create, that bottom part of the angle, match up. So, first step, go ahead and create an arc using where my original line and the line through my point go ahead and cross. So, brass ring right there, go ahead and create an arc right here like that. Remember which hole you used. Now go up to the point that we started with that was off of our line. Use that same hole. For me, first hole right here by the nice bold arrow. Again, same hole, make an arc. So all that we've done so far is we've made two arcs where this point up here and this point down here were the two vertices basically of my angles. Now, the other part that we have to come up with is to figure out how big this angle is so that I can recreate it up here. Well, I have a crisscross here, I have a crisscross here, so I can use those. Use your safety compass, come up here, right here where it crosses. Now come down here and figure out where it hits this line so that we can come up here and recreate it right here like that. Alright, there's where it crosses. Oh, right there. So, looks like that arrow right there. I'm going to come up here, do the same thing. And I've created two tiny little arcs here that copy that angle. You guys think back to your copy angle construction. That's all that we've done. Now that we have a crisscross here in our original dot, go ahead and connect the lines. Make sure that you do it correctly. And this line here is going to be parallel to our original line down here. Pretty nifty.
Now, what is an angle? An angle is a figure formed by two line segments or rays that meet at a common point. Angles are typically measured in degrees, which are measures of rotation from the x-axis. So an example of this would be here. We have ABC here. BC is a ray, and BA is a ray, and they meet here at point B. And it forms this kind of V shape here, which is an angle. Symbolic notation for angles. The symbolic notation for angles is angle ABC. So it's this kind of V shape here that represents angle. Then we label it as the points involved. Now notice that the point of intersection, or where they meet, or as we call it, the vertex, always goes in the middle. So B would have to be the center of it. So an example of this would be ABC. That would be our notation for the angle. Again, B always has to be in the middle. It could also be CBA. That would work as well, as long as B is in the middle. Geometric notation for angles. Angles are shown by labeling the points on the rays and the point of intersection. So an arc is typically drawn in the middle to represent the angle measure. Congruency and similarity. Congruent angles are angles that are of the same size, shape, and angle measure. Congruent angles are written as angle ABC is congruent to angle DEF. Again, the congruent symbol is the squiggly over the equal sign. Now, similar angles have the same shape and angle measure but are of different size, so they have different lengths. And we would say that then that angle ABC is similar to angle DEF, and the symbol for similar is the double squiggly. So congruency versus similarity. Congruent figures have all the same sizes. So notice all of my triangles here, both of my triangles, have exactly the same angle measures and same side lengths. They look exactly the same. That is congruent. Now similar means that it's blown up or shrunk down. So it's all the same size and shape. It's proportional, but it's not the same size. It blows up or shrinks down. So we can see that this triangle here is this one blown up. Geometric notation for congruent angles. Angles are typically drawn by labeling the points on the rays and the point of intersection. Congruent angles will have the arcs in the corner. So for instance, we have these two triangles here, and notice we have these arcs here in the corners. The single arc and the single arc mean that those two angles are congruent to each other. The double arc and double arc mean that those two angles are congruent to each other. And then the triple and triple mean that those are congruent. Now there's a video here for you to watch on how to construct congruent angles using Desmos. So go ahead and watch that video now. Let's take a look now at how we can construct congruent angles using Desmos. So we're given our angle here. First thing we need to do is create our pop-out menu. So now we have our tools, and we need to create a baseline that represents the same line as this one. So we use our ray tool and just create a baseline, just like that. Now, we need to find a way to create this line here. So the first way we do that is we're going to use the circle tool and go about this point just like this. And we can make this as big as we want or as small as we want. Smaller is usually better, so we'll go ahead and do that. So there's my circle. And now I need to copy this circle up to here. Well, we need a radius to be able to use our compass to copy it. So we need to create our radius first. So we use the segment tool and connect this point and this point. That gives us our radius. Now we can use our compass. So we go to More Tools, Compass, and we can click on this segment we just created. That's my radius. Notice if I place it over the top of this one, the circles completely overlap. So they're the same size circle. So we bring that up and place it here. And then we're going to put a point where the circle intersected our segment. So just like that. So now we have this point, this circle. Now we just need to create a point here that matches. So the way we're going to do that is we're going to create a radius using the segment tool from this point of intersection up to this point of intersection here. So there's my segment. Now we just need to copy that segment up to here. So we're going to use our compass again. So we go to More Tools, Compass, and we click on that. And now we're going to bring that up and place it right here at the intersection. And we know that this is the other point of intersection here. So it intersects both of them. So now that would be my point that I'm going to draw through. So I put a point here where they intersect. And then use my ray tool to connect this point through that point. And now this angle has the exact same measure as this one here. Now there's a video here as well for you to watch on how to construct congruent angles using paper and a compass. So go ahead and watch that video as well.
How to copy an angle using a safety compass. First, have an angle. Next, go ahead and use your safety compass and create a ray that will act as one of the sides for your angle. Right here, I've created basically one of the sides for my angle. Next, we have to figure out how big this gap is so that we can recreate it down here. The first move, go ahead and line up the brass ring on your safety compass with the vertex, or the corner here, of your angle. Then, make an arc all the way through your angle using any mark along the compass that you would like. I'm going to use this one right here next to a bold line. That way I can keep track of which one I use. Next, go ahead and come down to your new ray and recreate that movement using the same hole. Come down here. Again, same hole, same line for me. I've recreated that arc down here. Might look a little bit bigger, but that's because I went a little bit further around. Now, to figure out how big this gap is, use your safety compass, line up one of those points where it crisscrossed, come over here and line up the other point that crisscrosses. Looks like I might end up using the white inside part. Yep, right there. The very outside edge. Come down here, recreate the movement. Brass ring on the part that hits, just like I did up there. Again, use whichever hole that you used. For me, it was in here. For you guys, it might have been out here somewhere. Right, like that. So far, our two arcs are exactly the same. Which means, if I connect the vertex through that point, just like it is up here, I'll have recreated that exact same angle right down here. So go ahead and do that. Connect the vertex with the point where our two arcs intersected. And this angle is exactly the same as that. And that's how you copy an angle.
Now, what is an angle bisector? An angle bisector is a ray that divides an angle into two congruent angles. So it's basically going to take an angle and cut it in half. So bisecting an angle cuts it into two equal angles. The angles should have the exact same angle measure. For instance, we have our angle here in blue. If we were to cut it in half, it would look like this, and now this angle and this angle would be the same. Now, there's a video here for you to watch on how to construct a congruent angle using Desmos. So go ahead and watch that video now. Let's take a look now at how we can construct angle bisectors using Desmos. So we have our angle here. The first thing we need to do is create our menu. So we use our little pop-out menu. And what we need to do first is we're going to use a circle tool and extend it out. Just like that. And the only rule is it's got to pass through both points. Okay, that's the only rule we have. So now we're going to go ahead and put a point where it intersects the two segments. Next step is we're going to take our circle tool and we're going to draw a circle around this one. Just like that. So now we have our circle here. And if we copy this same circle here, wherever they intersect should be the bisector. So in order to do that, I need to create a radius. So I'm going to use the segment tool and connect this point with this point here. So that gives me a radius. Then I can copy that radius onto this one here. So I'm going to go more tools, compass, and I'm going to click on that segment I just created. So now it gives me a circle. And notice the circle is the same size as this one. I'm going to bring it down and place it right here. Just like that. And now I can put a point where they intersect right there. And I can use the ray tool to connect the vertex to that point of intersection right here. Just like that. And now I've perfectly cut this angle in half. Now there's a video here for you to watch as well on how to bisect an angle using paper and a compass. So go ahead and watch that video as well.
To bisect an angle, first have an angle. Next, have a compass. In this case, a nice safety compass. Go ahead and put that brass ring right on the vertex of your angle. Step 2, go ahead and create an arc that goes all the way through our angle. I'm just going to come out here and pick a nice mark. There we go. Doesn't matter how big or how small that arc is, make sure it goes through, because now the 2 points that we're concerned about is where that arc hits my angle. Those 2 points, super important. Those are going to be the 2 points that we use to find a bisector that's going to chop right through the middle here. Okay, so let's line up the little brass ring on our compass with one of those endpoints, and then create an arc out here in the middle. Make sure that it is big enough that it's actually going to be in the middle. Remember, a bisector chops it in half, which means if you're not somewhere here in the middle where that line's going to be, you're not doing yourself any good. So I'm going to create a nice arc here, obviously out here in the middle. Remember which hole you use there, because now you have to come over here and do the same thing. Just like we did over here, line up the brass ring with where our first arc hit the angle. Remember which hole you used, right there. Now, if you connect the vertex and that point where your 2 arcs crossed, that is going to perfectly bisect this angle. Let's see if it worked out. Oops. Alright, there we go. Don't worry about the little squiggle. Alright, now this top angle and bottom angle are perfectly congruent. same size, which means we can use these cool little congruent marks. And that's how you bisect an angle.
Now, what is scaling? Scaling is multiplying or dividing the length of a line segment or measure of an angle by some value. So, for instance, we can scale a line segment by copying the segment length and adding it to the end of the existing segment. Scaling an angle involves copying the angle measure and adding it to the end of the existing angle. So here's an example. We have a segment here. It goes from here to here. If we were to copy that afterwards, just extend it on and copy the same distance, now we've doubled it. If we did it again, we could triple it, and so on. Now here, with an angle, we have an angle that we start with, and here it is again. And then if we copy that angle on top of the existing one, now we have an angle that's exactly twice what we started with. Now here's a video showing you how to scale a line segment using Desmos. So go ahead and watch that video now. So let's take a look now at how to use Desmos to scale a line segment. So we're given a segment here, and we want to double it, make it twice as long. So we're going to go ahead and go to our tools. And the first thing we need to do is extend this line segment and make it go longer. So we're going to use the ray tool and click on this point and this point. And all that did was extend the line. Now we can copy this distance further down, and wherever it crosses, that should be where double the line segment would be. So we're going to use our compass tool because we already have our radius here. So we're going to click on that. And notice it gives me a circle with this radius. Well, I want this to start right here. Because now this is 1, and this would be exactly double right here. So we're going to go ahead and put a point where it intersects, and that would be exactly double our original segment. If we wanted to triple it, we would just do that process all over again. So this is how you can use Desmos to scale a line segment. Now there's a video here for you to watch on how to scale an angle using Desmos. So go ahead and watch that video now. Let's take a look now at how to scale an angle. So we're given an angle here. It looks almost like a right angle, and we're asked to double it. So this is how we're going to do it. So we're going to go to our tools. So all we're really going to do is create another angle that's exactly the same using one of these existing sides as our baseline. So we're going to do it the same way. So we're going to use the circle tool and extend it out. It can be as big or as small as we want it to be, just like that. And now we have a radius here, and the radius should be the same all the way around. So that helps us. So we're going to go ahead and use our segment tool to connect the dots. That gives us our radius here. And now what we really need is the radius that goes from here to here so that we can copy that somewhere else. So we're going to go ahead and put a point where the circle intersected this segment here. And then we're going to use a segment tool to connect them. Just like that. So now we have this distance. If we can copy that down here somewhere, that would give us the exact location of double the angle measure. So we're going to go to more tools and click on compass and click on this segment here. So we should notice that it's exactly where we want it to be. And if we place this at the center and click, notice there's a spot where these two circles overlap, and it's right here. So now all we need to do is connect the vertex through that point using our ray tool. So we'll go to ray, click on this point, and we can see that this angle here and this angle here are exactly the same, which means that this angle from all the way around is exactly double what we started with. Let's take a look now at the constructions review assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. It says, which of the following constructions represents an angle congruent to the angle shown below? So we want to find one where they created a congruent angle. Well, if we look at this one, it looks like they bisected that angle, so that's not right. This one looks like they created another angle, but notice this angle is a lot smaller than this one, so that's not right. This angle is much bigger than this one, so that's not right. This one looks like an angle that is congruent to this one, so the answer is C. Then we'll go ahead and scroll down to the next one. It says, which one of these following constructions represents an angle congruent to the original angle here? Well, if we notice, we have an angle here and an angle here. Those could be congruent. An angle here and here. This one could also be congruent, but it looks smaller than this one, so that one's out. Then we have this one that looks like it just doubled the angle. And then we have this one here where we bisected it, so that one's out, so it's got to be this one. And we'll continue to answer all these questions until we get to the end of the assignment. Once you get to the end of the assignment, we'll go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.